Hi guys, welcome to the class. In the previous lecture, we have discussed about coning of wheels, types of creep, and methods to eradicate the creep. In this lecture, we are going to discuss about types of rail joints and what are the different types of rail joints, and also what are the requirements of an ideal ballast, ideal fastenings, and the functions of a ballast, and what is meant by a ballast. We are having two types of rail joints based upon the position of the joints and positioning of the sleepers. Under the positioning of joints, we are having square joints and a staggered joint. In the positioning of sleepers, we are having suspended joint, support joint, and a bridge joint. What is a square joint? When a joint in one rail is exactly opposite to the joint in the parallel rail, it is called as a square joint. This is a very common type of joint in a straight track. If uh, while producing a straight parallel track, we have to form the rail end to the starting of the rail. The connections we give to the one end of the uh, laid rail to the second end of the leading rail. So while mentioning these joints, the joining of two ends at one point and same parallel line which is uh, followed by the laying up of a track, there are two parallel lines. These two parallel lines merge at same place while laying of a parallel straight path. So these joints, when we observe these joints, the joining of one end leading end to the tailing end of a track to opposite side of that, there is an another rail track, two tracks combining to two rails combined to form as a track. So these two rails have same joints on the same spot opposite to each other, then these joints are known as square joints. These are very common type of joints on a straight track path. These are also most preferred type of joints. And next one is staggered joint. Next one is staggered joint. When a joint in one rail is exactly opposite to the center of the parallel rail length, it is called as staggered length. When joint in one rail is exactly opposite to the center of parallel rail, these joints can be seen in the on the curved paths. And the major advantages of laying up of a staggered joints, the centrifugal force has a tendency to push the track out of line. Since the joints are the weakest points, they are more vulnerable, but staggered joints resist them to a great extent. If in the previous joint, in the square joint, we have seen that these joints find quite opposite to the next track, next rail. Similarly, in this, it is quite opposite for a staggered joint. So here we can observe if one joint, if we consider this is a rail and another one, this here is itself a rail. If a joint has been produced, has been placed here same as another track with a joint here, then these type of joints which are quite opposite to each other is known as a square joint. And for the staggered joint, if a joint has been appeared here, and for the same track the joint is in the center of the parallel line. So the another joint may be of its here itself. So this has more tendency, the centrifugal force of the locomotive has a tendency to push the track out of line if the joint is of square joint. But if this joint is of a staggered joint, the centrifugal force can't have much tendency to push the track out of the lane, but these staggered joints resist them to a great extent, because their joints can't be at a same point on the opposite side. There are some, if joint has been seen for in the, if we consider these margin lines as a rail, and these uh, line is also a rail track. By observing, if a joint has been seen here similar to that of opposite side here, these joints is known as square joint. And if you have to know about a staggered joint, if a joint has been here and the other track which is in the middle of the rail, this is the middle of the rail, so there must be a joint at some other point like here, and some other point like here. So the joint has been seen in the middle of the rail opposite to the different rail. So these joint has much tendency to resist the centrifugal force which push the track out of lane. It is more uniform, vertical continuity of the track is formed, produce more smooth running than square joints, produce more smooth running than compared to that of square joints. The possibility of forming kinks will be decreased. In the previous class, in the previous lecture, we have discussed kinks can be formed, and the rupture and the failure of the rail has been observed if kinks are formed. So the possibility, if we applied a joint like staggered joint, the possibility of forming kinks will be decreased and decreases the vertical distance of wheels. Yeah, the joints are in opposite direction. Same uh, jolting effect can't be seen in these staggered joints. The number of impacts at joints are doubled, but intensity is half. But the intensity of the uh, locomotive intensity on the locomotive is half when compared to that of square joint. The number of sleepers per rail length will be increased by one, because the number of joints not opposite to each other, they are parallel but at the center of the opposite track. So another sleeper will be increased. Only one of the number of sleeper has been increased at the joint. For the square joint, it not be any increase in sleepers, because their joints has been in a symmetric pattern in the straight path in the opposite to each other condition. The staggered joints are more adopted on sharp curves and not favored on straight track. These staggered joints are more favorable and adopted on sharp curves but not on a straight track. It is not a rigid rule to fix the rail exactly at the center. The suspended joints here, based upon the positioning of sleepers, we can see the suspended joints. The rail joint, when placed at the center of two consecutive sleepers, is known as suspended joints. The rail joint, which is placed at the center of the consecutive sleepers, is known as suspended joints. The load is equally distributed on sleepers when the joint is pressed down. Both the rail ends are pressed down evenly. when the joint is pressed down, both the rail ends are pressed down evenly. These are more commonly adopted joints. They provide greater elasticity to the track because they cause less disturbance to the wave motion of track. These require more maintenance. These require more maintenance. In the supported joints, the sleeper is placed exactly below the joint. It appears like rails are supported at weakest parts. Those are not used at present. Supported joint did not give sufficient support to the heavy axial loads. Supported joint did not give sufficient support to the heavy axial loads. If the joint is packed too hard, it prevents it from settling at times. It leads to the battering of rails as wave motion is not carried uniformly. Next one, the bridge joint. It is similar to that of suspended joint. Difference is a sufficient length of metal is used to connect the ends of two rails so that there is no bending stress in the rail. If the bridge is placed at bottom of the rails and rests on sleepers, the sleepers at the end will have to be notched out at the sides or will have to be placed at lower levels than the other sleepers to accommodate this bridge joint. The bridge joint is similar to that kind of suspended joint, but these bridge joints are placed beneath the rails. So the sleepers which we provide below the bridge joints can be lowered when compared to the nominal sleepers or normal sleepers we place at the level surface is different when compared to the bridge joint applied beneath the rails. So the end sleepers are supposed to work as unyielding fixed supports, but practically they are not working as fixed unyielding supports. As a compromise between supported and bridge joints, the Indian rails provide semi-supported joints. The sleepers at rail joints are bought close here in this case. So the major these end sleepers are supposed to work as unyielding fixed supports, unyielding fixed supports, but practically they are not working as a fixed unyielding supports. The unyielding supports which reduces the load applied on the rail. So these are not practically in working condition as fixed unyielding supports. Sleepers at rail joints are bought close here in this case. Requirements of the ideal fastenings. The good fastening connecting rail and sleepers plays a vital role in improving the efficiency of railway track. The capable of absorbing shocks and vibrations, and these fastenings are capable of giving protection to the sleeper against different forces. We provide insulation in case of electrified tracks. If we provide insulation in case of electrified tracks, and they are capable of resisting the creep if, and they are also capable of securing the correct gauge length and be economical. They consist of minimum equipment and also durable. the, they are easy to fix and adjust if any renewals is happening. They are easy to renewal also. They are non-corrosive. The ideal fastening should be as a non-corrosive member and easy to fix and adjust these ideal fastenings. So it should have sufficient strength to resist damage due to derailment. These are the basic and requirements of a ideal fastenings. First one is they are capable of absorbing shocks and vibrations which are taken by the rails. That jolting effect when the rail in the locomotive wheel and axial loads move towards the joints of the rails, they can absorb heavy shocks when compared to the smooth moving on the parallel track. So while the shocks and vibrations that are absorbed to the rails, they have to be effectively safeguarded by the fastenings provided to the rail and sleeper. These fastenings plays a vital role and have to be efficiency in improving the railway track. The fastening we provide must be and economical, and it has a long life and easy to fix and adjust. These fastenings we provide should be of non-corrosive material and also give sufficient strength to resist the damage when the derailing of locomotive happens. These fastenings can have sufficient strength to withhold the positioning of rail and to the sleeper. These are also possible to remove only using special tools. These ideal fastenings are possible to remove only by using of ideal tools or special tools. These should safeguard the alignment in all the aspects. These should not adversely affect the rails and sleepers. If we bantered, uh, if we immersed these fastening into the rail to the slipper, these fastenings helps to maintain the balance of the rail in that particular position within the posture that has been placed with respect to that of sleeper. So so these fastenings cannot affect the rail and the sleepers. These ideal fastenings can't affect. If we fix the fastenings into the rail to safeguard with the sleeper, these fastenings can also damage if the manufacturing of the steel, if the manufacturing of the fastenings are high of good qualities, and when the RCC member or the wooden sleepers we used, when we mm, fixed these fastenings into the rail to the sleeper, the sleepers may collapse, the sleepers may be damaged, the sleepers may be splitted towards ends, the sleepers can also be endangered. So these fastenings, the ideal fastening should not adversely affect the rail and sleepers, and these should not be too rigid. The adequate strength to resist lateral forces and should possess high torque resistance. Should also possess high torque resistance. Next, ballast. What is ballast? The material placed between the sleeper and the top of the formation is known as ballast. There are of so many types of ballasts we can observe. The main ballast, the major parts of the Indian railways we are nowadays having is of how ballast of type aggregates. So the load from the wheels will be taken up by the ballast through rails and sleepers. The locomotive that passes over the rail should transfer the load of that locomotive to rail that insist transfer to the sleepers. These sleepers and rails, they both add these transfer these loads to ballast. So these ballast serves as foundation of railway track, and in present just below the and it is present just below the sleepers. To maintain the load that is transferred by the rails to the sleepers and sleepers to the ballast. The major functions of the ballast. The major functions to provide a hard and smooth surface for the ballast to rest on, and to hold the sleepers in place during the passage of trains, to transmit and distribute the load from sleepers to formation bed, to transmit and distribute the load from sleepers to the formation layer of ballast, and allow for maintaining correct track levels without disturbing the railroad bed. Allow the maintaining allowed for maintaining correct track levels without disturbing the railroad bed, to protect the surface of formation from direct exposure to sun, frost, or rain. Protect the surface of formation from directly exposure to sun, frost, or rain, and to form an elastic bed. The major functions of the ballast is to hold the sleepers in their position while the passage of trains occurs, and also to transmit and distribute the loads from the sleepers to the formation bed. So these ballasts are also helpful for the surface formation from direct exposure to sun, frost, or rain, and also form an elastic bed. They also to drain the water immediately and keep the sleepers in dry conditions. These ballasts are also having a good function to drain the water immediately and keep the sleepers in dry condition, to discourage the growth of vegetations, to resist lateral, longitudinal, and vertical displacement of track, to discourage the growth of natural vegetation on the uh, formation of railway bed. So the sleepers only inhabited with the ballast, that cannot have natural growth of vegetation there. And also in the rainy seasons, these ballasts keep the sleepers in a dry conditions, to resist lateral, longitudinal, and vertical displacement of track. What are the good characteristics of ballast? It should have sufficient strength to resist crushing under heavy loads of moving trains. These the major characteristics of a good ballast is to resist the loads that are applied by the moving locomotive. So the ballast can't be crushed. To withstand these loads, a good quality of ballast has to be used. It should be durable enough to resist abrasion and weathering actions, and it should have a rough and angular surface to provide good lateral and longitudinal stability to the sleepers. Should have good workability and have easy spread of formation. Should be cheaply available. Should not have any chemical action on metal sleepers and rails. While talking about good characteristics of a ballast, these ballasts can not be crushed by continuous applying of load by the moving trains, and these ballasts can't can't show any chemical actions on metal sleepers and rails. These are very easy to workable and easy to spread for formation bed. So, and are also should be cheaply available. What are the requirements of ideal material for ballast? These should be possible to maintain an uniform depth of material for uniformly distributing the load to the formation. It should provide sufficient grip over the sleepers to prevent their movement. Ballast should not be too rigid. It should be elastic in nature. The material of ballast should not be brittle, should possess required compressive strength, should provide good drainage facility, and also cheaply and easily available. These should not show any chemical action on rails and metal sleepers, should be durable and abrasion resistant. Types of ballast we use are broken stone, gravel, ashes or cinders, sand, conker, muram, brickbats, and selected earth. Broken stone. It is one of the best material but expensive material for the ballast formations. Many important tracks are having stone ballast. Possesses all characteristics of good ballast, and it has good interlocking characteristics. Due to that, it holds track in correct alignment and gradient. It is resistant to abrasion, provides good drainage. Stones which are non-porous, hard and tough should be used as a ballast when compared to broken stone. Granite is a best material, best but quartz, sandstone, limestone are also used as a ballast. The broken stone, which is economical, which is way expensive, so these possess good characteristics of a ballast, but the expensive nature is of not in use of broken stone. Gravel. It is next best material after the broken stone. It consists of smooth, rounded fragments obtained from riverbeds and other natural deposits. Washing should be done for the material obtained from pits. Uniform and required size of aggregates should be used. Rounded pieces are sometimes broken to improve interlocking properties. To improve these interlocking properties, the rounded pieces of the gravel should be broken into small pieces, and the major advantages are: this is cheaper than stone ballast and have good drainage property. The major disadvantages are easily rolls down due to vibration. Ashes or cinders. The residue from the coal used in locomotives and other furnaces is known as the ashes or cinders. It is the byproduct of railway systems which are run by the coal fuel. The major advantages of using these ashes or cinders are: good drainage properties can be obtained and also used in ads to keep them dry. Handling is easy, low cost, and easily available. Can be used for repairing formations and packing during emergency. The major disadvantage we face by using of these ashes or cinders are they are very soft, easily becomes powder, hence track becomes loose, and the sleepers which are maintained to be in position can change, can alter their position. So these are one of the fine materials but having major disadvantage of easily becoming powder. Sand. Coarse sand is preferred to fine sand. This is not used in main branch lines, so these are used only in some unimportant lines, sidings, and yards. The major advantage of using this sand as a ballast is if the sand is pure, possesses excellent drainage property, produces a silent track, cheap and easily available. The major disadvantage while we using this sand as a ballast are frequent renewal is required, disturbed easily by vibrations, more maintenance required, causes more friction, and leads to abrasion and wearing losses. So, these sand particles, the major disadvantages of using these sand particles as a ballast are these causes more friction and leads to abrasion, and wearing of rail can be seen If the sand particles are uh, in place between the rail and wheel of the locomotive, the wear of the rail can be maximized by using these sand as a ballast. So the sand particles, the broken stone materials which we used in earlier is the best quality, but it is of economical. The investment for the earlier stages of the laying up of a track is high when compared to that of other materials. Conker. This is found in many places and suitable only if other types of material is not available, and if the traffic is less on meter gauge and narrow gauge. It becomes powder very easily and hence not preferred. More maintenance is required if used. If we use Conker as a ballast beneath the layer of the sleepers, these Conkers are easily available but can become powder easily by the because they can't load the base of the moving locomotive. So these Conkers can be easily powdered, and the maintenance is very high when compared to that of broken stone ballast. Murram. The decomposition of laterite results in the formation of murram. They are present in red, yellow in color. These are used for unimportant lines and side links. The major advantages of using these murram as a ballast is of it can be safely used on a newly laid track. It serves as soiling. When the stone ballast is laid afterwards, they possess good drainage properties. So, whatever the ballast we use here, like broken stone, sand, conker, murram, whatever it may be, they all possess good drainage, but these are all required high maintenance when compared to that of broken stone. The major disadvantage while using these murram as a ballast is of they soft and turns into dust very easily, and the maintenance is very difficult when the murram ballast when the murram ballast powdered. These maintenance is very difficult when the loads on the ballast is increased. The murram gets the ballast gets powdered. So while renewal of this ballast layer is very difficult. So the broken stone is used as a ballast, uh, but it should be a bit of economical when compared to these all type of ballasts. The brickbats. Over burnt bricks are broken into suitable sizes and used as a ballast. The major advantages in the using of brickbats as a ballast are they are useful at places where suitable material is not available. Good drainage properties. They possess good drainage properties. The major disadvantages of using brickbats as a ballast are they turns into powder form very easily because they can't take heavy loads on, so they turns into powder form very easily. Tracks becomes dusty and high maintenance is required. The rails are often corrugated on tracks where brickbats are used as ballast. So the selected earth parts. For sidings and newly constructed tracks, selected earth of suitable quantity is sometimes used as ballast. The main purpose of using earth on new formation is to prevent the loss of valuable and expensive ballast sinking into the soft formation. While laying up of a new railway track, these selected earth of high quantity, suitable quantity is used because while applying the constant loading of a locomotive on the rails to the sleepers, these formations these formations can be synced. So if we use the expensive ballast on the newly laid tracks, newly laid railway tracks, these formations, these tracks we laid can be synced into the soft soil. So we use a selected earth as a ballast in the early stages of new railway tracks. The specifications of stone ballast. The specifications of stone ballast. Quality. The quality should be durable, hard, resilient to impact, and free from adherent coatings. They should not contain more than 10% by weight of quarry dust, rubbish, or any other matters which passes through 5 mm sieve. The faces of ballast should result from crushing. Only one smooth surface is allowed. The quality of this stone ballast must be durable, hard, and resilient to the loads. To withstand these loads, they have to be resilient and more hard, and also should have high durable, high span of life, and they are free from adherent coatings. They should not contain more than 10% by weight of quarry dust. So the nominal size of stone ballast we use are 20 to 50 size with reasonable proportions of intermediate sizes. If we use 50 for wooden and cast iron sleepers, and 40 for uh, central CST 9 Central Standard Track 9 sleepers. So 25 at the points and crossings of the railway routes. The nominal sizes we use are 20 to 50 They are of different conditions on based on the specifications. These 20 to 50 aggregates are used. Specifications of stone ballast. The grading. The ballast should be well graded so that it can have to be arranged in a place to withstand these heavy loads of the locomotive. The sampling. The sample of ballast is to be collected at the rate of 1 cubic meter per 200. Oversized ballast. When more than 10% of ballast retains on nominal size sieve, it is called oversized ballast. When the ballast we are using as a formation bed for the rails, these ballast should not be more than 10% of the ballast that retains on nominal size of sieve. Then it is called as oversized ballast. Staking. The ballast should be stacked along the quarry sidings. The height of stack should not be less than 120 centimeters. The height of these ballast stackings, where the requirements of the new railway route has been sanctioned, the allowance of a stack of these aggregates of these ballast should not be less than 120 centimeters of height. So here you can observe size of the ballast and sieve size with a square mesh of 65 and 50 these on above 65 sieve we have placed these 50 size of ballast. They have to be 100% passed through the sieve from 65 and should retain 90 to 100% on 50 sieve. If we use different size of ballast like 40 size, we have to use the upper sieve as of dimensions, square mesh of dimensions 50 and they have to be sieved through 100% and should retain on the 40 sieve of about 90 to 100%. If you are using 25 size of the ballast, the 40 sieve is used as the upper sieve size with a square mesh of 40 and they have to be passed 100% on 40 while using up of 25 and should retain on the 25 sieve with 90 to 100%. If more than that 10% of the sieves that have to be passed through 25 are have to be retained at 40 should be considered as oversized ballast. The depth of ballast section, the depth of ballast section can be calculated by using the formula. D is equal to, D is the depth of the ballast section, and S is the sleeper spacing, B is the width of the sleeper. If the depth of the ballast section can be find out when capital D is the depth is equal to S minus B by 2. The normally the value ranges in between 20 to 25 centimeters from the above formula. The section of the ballast, here you can observe this is the sleeper and these are the rails we provide, this is the gauge length, and here in 1.5:1 ratio the stacking of these formation of the ballast layer has been placed here, and the slope must be of 1:1.5. So the stacking that should not be more than that of 120 centimeters in height. The super elevations on the curved path should be of 15 centimeters. The inner rail is downward when compared to that of outer rail. Here we have details of ballast section. For a broad gauge, we are having of width of the ballast section is 335.3 centimeters, and the depth of the ballast sleeper is 22-32 centimeters, and quantity of the ballast in meters or length is of 1.12. The meter for a meter gauge it is of 2 to 9.6 of width of ballast section, and 15 to 25 depth of ballast below the sleeper. For a narrow gauge it is of 183.0 width of the ballast section, and the depth is of 15 to 17 centimeters. Screening of ballast renewal. So ballast used on the railway track is to be renewed from time to time due to the following reasons. The ballast gets powdered due to the hammering of wheels. These fills voids in the ballast layer, forming impermeability. The ballast get pressed into formation. The available ballast quantity gets reduced with time. The elasticity will also gets disturbed. To avoid and remove all these effects, ballast is cleaned at regular intervals by means of screening. The process of screening is of the surface will be normally clean. Hence, ballast forks are used for cleaning. Dirty ballast is made loose by means of equipment such as picks. So, frames of size 150 into 120 centimeters with expanded metal mesh are put parallel to the track. The dirty ballast thrown onto the mesh to separate the dirt and the aggregate ballast. These required quantity of additional ballast is added to screened ballast to make up the deficiency. Thank you. Meet you in the next class.